All right, so another integration technique is called integration by parts, and we're splitting this up into 2 days. Day one is the day that teaches you the basic concepts and does more examples, and day two just shows you another example. So this is useful for trying to integrate when you have the product of two functions, in particular an algebraic function and a transcendental function. A transcendental function would be like an exponential function, a trig function, a natural log function, or an inverse trig. So here are three examples where you would have two functions multiplied together where you would have to use integration by parts. The formula that you're going to use when you're applying integration by parts is your integral is u times dv. So it's some function u and it's some derivative of a function. And that turns into the integral of u times v minus the integral of v du. I know that sounds confusing right now, but it'll make sense in a second. So what you're going to do is you're going to use the acronym LIPIT to choose your u. So the L stands for logarithmic. The I stands for, oh my gosh, that's an L. The I stands for inverse trig. The P stands for a polynomial. Just x to the first is a polynomial. So x to the first, x squared, polynomial. Can't write with this. E stands for exponential. And T stands for trig. That's how you pick your u. That's the order you pick u. So let's just put that into place here. So remember, you're trying everything else first. You're not doing integration by parts unless you have to. So I would look at this and I would see an exponential. I try to make u the exponent. The du, it doesn't work. So then you say to yourself, okay, this is a function times another function, and it has a algebraic function multiplied with a transcendental. So when you realize it's integration by parts, let me leave some room here. You're gonna have to pick your u first, and your u is based on the acronym LIPIT. So is there any logs in here? No. Is there any inverse trig in here? No. Is there a polynomial in here? Yes. The x to the first is a polynomial. So you make u x. That means dv would be the rest of it. So it would be e to the x dx. Because remember, when we realize it's integration by parts, we're integrating u dv. So we have to state what our u is, and we have to state what our dv is. And when we integrate that, it becomes uv minus the integral of v du. Okay, so we need our u and our dv, and then from there we're going to find our du, which is just the derivative, so it's dx. And dv to v, what do you think you're going to have to do? You're going to have to integrate, so it'd be e to the x. So what we're doing is this ends up being u times v, so x, e to the x, minus the integral of v, which is e to the x, times du, which is dx. So I wrote out the formula for integration by parts, and now this second integral, I actually have to integrate it. So when we integrate e to the x, it just becomes e to the x plus c. So here's your answer. So when you notice you're integrating a function times another function, you think to yourself, maybe this is integration by parts, and you go ahead by trying to pick your u first, and then once you have your u, you're stating your dv. So looking at number 2, going by LIPIT, okay? Logs, yes. So there is a log in here. That's what I make my u. My dv would be everything else. So that's the x squared dx. So to go from u to du, I derive, so it'd be 1 over x dx. To go from dv to v, I integrate, so it'd be x cubed over 3. And hold off on the plus c because we're going to have that on the end. So integration by parts said u times v. So always put the polynomial term out in front. So u times v minus the integral of v times du. V times du, there's going to be a 1/3. Pull out any constants right away. And when I do v times du, I'm going to have x cubed over x times dx. And remember, I pulled that 1/3 out. So this is really integrating x squared. And that's no big deal. So integrating, let me write the rest. X squared is x to the third over 3. Now the 1/3 in that over 3 becomes 9 on the bottom. And there you go. There's integration by parts. So you got to know this formula right here. The integral of u dv is uv minus the integral of v du. And you use limit to pick your u, and everything else from there is a little bit easier. Okay. So I might as well write this out here. Equals uv minus the integral of v du. All right. So arc sine, okay? You're probably thinking, oh, we have a formula for that. No, we don't. We have a formula for something that integrates into arc sine. We never actually integrated inverse trig before. So when you see inverse trig like this, it's automatically integration by parts. So when you try to pick your u based on limit, logs, no, inverse trig, yes. So u is arc sine x. dv is as simple as just dx. Okay, remember, it's the rest of it. My du is the derivative arc sine. So you need to know the derivative arc sine, but you're going to have a formula. So derivative of the inside over the square root of 1 minus the inside squared. That's the derivative of arc sine. To get back to v, I need to integrate. So I'm integrating 1, so that's just going to be x. All right, so when I write this out, this is getting slow again. It's going to be u times v, so it's x, arc sine of x, of v du, so it's going to be x over root 1 minus x squared dx. Okay, so this is x, arc sine of x. So here, if I make u the inside, when I go to integrate this, du is negative 2x dx. So I've technically put a negative 2 in and a negative 1/2 on the outside, which makes it positive 1/2. The integral of, this is u to the negative 1/2 du that we're integrating, not du over u, it's du over u to the 1/2. So I bring it up. And when I integrate this, it's u to the 1/2 divided by 1/2. It's the same thing as multiplying by 2. And don't forget, you had the 1/2 in front. So those will cancel. So we're just left with plus root 1 minus x squared. Now, I'm not going to put the plus c. And the reason being is I have these bounds to still plug in. Which bound do you plug in first? Good, the top bound. So 1 times arc sine of 1 plus the square root of, when I plug 1 in, I get 0. Then I minus, take 0, plug it in. So 0 times anything is 0, plus the square root of 1, which is just going to be 1. So I'm subtracting 1 here, okay? Arc sine of 1. So sine of what angle is 1? So where in the unit circle is the y value 1? That would be at pi over 2. So your final answer here would be pi over 2 minus 1. All right, and last thing, okay? There's something called repeated parts. It means that you'd have to use parts multiple times, and that's a pain in the butt. So when you recognize you have to use parts multiple times, you're going to use something called a tabular method, but you got to know these forms. You've got to be able to recognize, like, hey, it's in one of these three forms. That's going to be repeated parts. Let me use tabular method. Okay, so looking at number 4, it looks like the first example here. So when you realize it's the repeated parts, what you're going to do is you're going to set up a chart. And it's going to have a chart with U and dV labeled at the top. You pick your U the same way with Lipit. So logs, no. Inverse trig, no. Polynomials, yes. So your U is x squared, okay? Your dV is everything else, sine x. And you can put the dx in there, but not super important to do that for this case. So your U, what you're going to do is you're going to keep deriving till you get down to 0. That's how you know you're done. Your dV, you're going to integrate as many times as it took to derive to get down to 0. So I'm going to have to integrate one time here, so I get negative cosine x. Be careful when you integrate the signs. When I integrate negative cosine, I get negative sine. And when I integrate again, I get cosine. Okay? So I integrated the same number of times as I derived to get down to 0. Now, here's the new thing, right? We're going to multiply diagonally. And when I multiply the diagonals, I start with positive, then negative, then positive. That's the sign. So you have to incorporate those signs. So ready? Your answer is literally right here. You don't have to do anything else once you figure out this table. So x squared times negative cosine x is negative x squared cosine x. That's your first part of your answer. And then we're doing 2x times negative sine x, but you have this extra negative, so it really makes it positive. So it'd be plus 2x sine x. And then the last part here, 2 times cosine x is 2 cosine x plus c. And there's your answer. It's that easy, okay? So if you don't recognize its repeated parts and you can use tabular method, it's a pain in the butt that you'd have to do integration by parts like we did above multiple times. So look at this example, number 5. It looks like this repeated parts example. So as soon as we realize that, we're going to set up a table for the tabular method. We're going to pick our U the same way with Lipit. L is logs. No, there's no logs. I is inverse trig. No inverse trig. P is polynomials. Yes, x cubed is a polynomial. So till we get down to what? Till we get down to 0. Okay. Our dV would be e to the 5x, and we integrate the same number of times it takes to get down to 0. So be careful when you integrate, it's 1/5 e to the 5x, right? Because you have a u is 5x, du is 5, you have to put a 5 in, and a 1/5 on the outside. So then this ends up being 1/25 e to the 5x. Then 1 over 1/25 e to the 5x. Then 1 over 625 e to the 5x. All right, let me make sure my math is good here. Okay, so next thing we do is we multiply the diagonal and alternate signs. So this is plus, minus, plus, minus. Okay, and your answer is right here, so we're going to write it out. So x cubed times 1/5 e to the 5x. That's 1/5 x cubed e to the 5x. Okay, then minus 3x squared times 1/25 e to the 5x is 3 over 25 x squared e to the 5x. The next one is 6 over 125 x e to the 5x, and then minus 6 over 625 e to the 5x plus c. If you could reduce your fractions, you would. And here's your answer. All right, and the last one here. It doesn't quite look like this third repeated parts problem, because look, this is only supposed to be x, and this is x cubed. Remember, you're not doing integration by parts or partial fractions unless you absolutely have to. Check u and du first. When you have an exponential here, what do you think you're going to try u as? X cubed. And the derivative is 3x squared dx. Look, that's already in there. So you just need to put in a 3 and a 1/3 on the outside. And here you're just integrating e to the u du. And e to the u integrates to e to the u plus c. Heck of a lot easier. So check your old methods first, guys. Don't do more work unless you have to. All right, remember, you're using the acronym LIPIT to choose your u. L stands for logs, I is inverse trig, then polynomial, exponential trig, and the integral for parts is the integral of u dv. Thinking ahead. U dv minus the integral, or hold on. Okay. Start this over, Palumbo. The integral of u dv equals uv minus the integral v du. Okay, there you go.